our subject today is soil mechanics. Here is the content or outline of our subject. This chapter is introduction to soil mechanics, and for the second is soil investigation. Yeah. So after we finish introduction to soil mechanics, yeah, like origin or formation of soil, how soil accumulate or occur, we continue to chapter 2 is soil investigation. I will introduce and teach you how to do a soil investigation, what step we will do in soil investigation. And chapter 3 is soil particle size classification. Yes. So soil have like sand, gravel, silt, or clay. So how we classify them according to the particle size, using several standards like ASTM, ASTO, or USCS, soil particle size classification. And for chapter 4 is weight volume relationship. We will study a lot of soil parameter in lesson 4. That is the relationship between weight and volume of soil, and we can find more soil parameter from this lesson. And for chapter 5 in our subject is Adiabatic limit. Adiabatic limit is very important for doing soil classification. Before we can classify the soil, we must know how liquid limit or plastic limit of the soil, and then we can classify the soil like clay or sand. After that, for chapter 6 is soil classification. So as I mentioned before, for doing soil classification, we have to know a percent of soil, like a percent of sand, silt, clay, that we will learn in chapter 3, soil particle size classification. And combined with chapter 5 is liquid limit. Adiabatic limit, we refer to liquid limit and plastic limit of soil. From that parameter, we can use to classify the soil. I mean to find name of soil, follow standard, mostly ASTM or ASTO. And for chapter 7 is soil compaction and CBO. Soil compaction is very important for construction, like road embankment or foundation, shallow foundation. So before we construct any structure, especially like road, every layer, we need to compact the soil to reduce pore or increase the unit weight and bearing capacity of the soil. For chapter 8 is method control of field compaction. Yes, it's also important when we compact the soil at the field, like compact soil for road construction. We need to control or check, how it compacted. If the compaction is not past the design specification, we need to recompaction or remove the soil and fill new soil or material to compact again, or we need more energy to compaction like that. So to know it is well compaction or not, we need to control the field compaction, to control of the compaction at the field during construction. For chapter 9, we will learn about shear strength of soil. Shear strength of soil related to soil cohesion, soil cohesion or and friction angle of soil. Those parameters is very important for, especially for foundation design, retaining wall design. We need to use soil parameter from shear strength of soil, like unconfined compression test or direct shear test. Yes. And for chapter 10, we will learn about compressibility of soil. When we construct any structure on the ground, so the foundation will transfer a lot to the soil, and soil will be compressed. So in chapter 10, we will learn about compressibility of soil when we apply load, the coefficient of compression, when we loading, and coefficient of swelling when we unloading. So I will more detail in each subject later. And for chapter 11 is permeability of soil. Permeability of soil is important for especially for dam construction. Earth dam construction. We need to study or know how water flows through soil and how fast, like sand, clay, or another material, how it allow water flow through the soil mass. For chapter 12, we will learn about in situ stress. The word in situ is referred to site or field or in natural ground at the site, or in natural. In situ stress is also important chapter that we have to know, like total stress, for example, underground. It has stress, soil stress, because soil stress or in situ soil stress, because of the shape way of the soil. From that parameter, we use it for analysis such as foundation or retaining wall as well. So before we go to design any foundation, we need to know how is the soil stress, like total stress, effective stress, or water pressure at any deep and underground. Last chapter for our soil mechanics class, we learn about stress in soil mass. Stress in soil mass, it will focus on the increasing stress when we apply load on the ground, such as foundation. It is additional stress to the in situ stress. In situ stress is the stress in natural, we call a natural stress. And when we apply load, so at any point on the ground, it will increase. The stress increase due to loading from the superstructure. For chapter 1, we will learn about introduction, introduction to soil mechanics. So here is the keyword, some keyword in our lesson, like soil. Yes, soil are material that are derived from the weathering of rocks. Yeah. Rock is the parent material of soil. When it's weathering, become to soil. Yes, and mineral are chemical element that constitute rock. In rock, there are many mineral, yes, that constitute rock. Rock are the aggregation of mineral into hard mass. Yeah. When mineral or bind together, yeah, to be a hard mass, we call it rock. Due to high temperature, high pressure, and very deep below the ground surface, and it takes a long time to become rock. Another keyword is residual soil. Soil that remain at the place of formation we call residual soil. For example, when the rock weathering become a small element, that we can say a soil particle. Transported soil is soil that move and deposit to another place of formation. Yeah. So when the rock is withering, become soil, and soil, and that soil we move or transport it from the original place to another place. Yeah, that we call transported soil, like move by air or river, stream, and another like water flow. Another keyword is soil mechanics. That is our subject. It is the study of the physical property of soil, like grain size, and the behavior of soil mass subjected to various type of force. Yeah. Behavior of soil. When we apply a lot, so how the soil deform, or how the soil is settled. So soil mechanics is the study of physical property of soil and the behavior of soil mass subjected to various type of force. Okay, these they are just some keywords that will appear in our first chapter. Okay, now move to our content of the lesson. What is soil? You can see here soil have different grain size, different color, like black, gray, dark gray, yellow, red. So soil are natural resources. Okay? It is natural resources. They are necessary for our existence. They provide food, shelter, construction material, etc. Soil protect the environment and provide support for our building. Yes. So it can protect the environment and provide support for our building. All construction or structure stand on soil. So we need to know about soil parameter, soil property, how it can support the building or any structure. Okay, you can see in the figure, yes, you saw a soil block. For example, we take the soil from side, and if we separate it, it has three main components. That is, we call solid. Solid is referred to soil grain or soil particle. Right? in natural, and liquid. Between the soil particle, it can be filled by liquid like water, oil, and also gas. Yeah. So between the soil particle can filled by liquid and gas, yeah, in natural. Yes, this solid that refer to soil particle or soil grain, and some liquid surrounding the particle also have gas that we refer to air, yeah, or another gas like hydrogen. What is soil formation? Yeah. Soil formation is the process by which soil is formed as a result of interaction over time between parent material, that is rock, climate, topography, and organism. Soil formation is the process by which soil is formed as a result of interaction. Interaction over time between rock with another factor like climate, topography, or other organism. The process is called weathering of rock. That process we call weathering of rock. You can see in the photo show about weathering of rock for 100 or 1,000 years. It will become like this. So the weathering of rock, they divide it into two. The first is mechanical weathering of rock, okay, and the second is chemical weathering of rock. So rock can be can be weathering by two ways. First is mechanical weathering, and the second is chemical weathering. What is mechanical weathering of rock? I mentioned before, rock can be weathered by two ways. Yes, mechanical weathering and chemical weathering. And now, what is mechanical weathering of rock? Mechanical weathering of rock involve reduction of size. It means the large size becomes small or space or piece, without any change in the original composition of parent rock. We call it mechanical weathering. Again, mechanical weathering involves reduction of size without any change in the original composition of parent rock. It means still keep the same composition, but it reduces the size. And how it reduces the size? Mechanical weathering process include we call frost action, abrasion, and exfoliation. The rock can be reduced size or can be weathering by we call mechanical weathering. Have 3 points. First is frost action. Second is abrasion, and third is exfoliation. Now, what is frost action? As you can see in the picture, we have rock and some crack or some hole that can be filled by water, and later when the water is get cooling and it is fresh. So it volume will change, increase. You know, when water is fresh, so it will increase, increase the volume. That can break up of rock that the water fill in the gap or crack, and when it flashing, it will have some force to push out the rock, and the rock can be cracked or can be break up. Yeah. So flow action is the break up of rock caused by flashing and throbbing, that we call contracting or expansion. Yeah, expansion or increase its volume, yeah, or water. That we call is flow action. That is one of the mechanical weathering process. This phenomenon can occur at some country that have low temperature. Sometimes it become fresh, like a pole zone. Abrasion. You can see in the picture. So rock aggregate become rounded. So abrasion is the mechanical wearing down of rock as they rub, as they rub or bound against each other. You can see in picture is showing rock that move or transported from one place to another place, and it can be abrasion due to the rock is movement by water flowing or by topography. So abrasion is the mechanical wearing down of rock as they rub or bound against each other. The process is most common in windy area, under glacier or in stream channel. If you go to see, if you go to visit some stream channel, you can see rock nearby the channel have a round shape, like in this photo, due to the abrasion. Rock on a beach are worn down by abrasion as passing waves cause them to rub each other, in the photo. Another one is exfoliation. That is one of the mechanical weathering process. Another one of mechanical weathering process we call exfoliation. Exfoliation is the peeling away of large sheet of loosened material at the surface of a rock. You can see in the photo is, you can see the loosened material outside at the surface of the rock. It can be peeling away of the sheet or loosened material, that we call exfoliation. It is one type of mechanical weathering also. So again, mechanical weathering process included flow action, abrasion, and exfoliation. What is chemical weathering of rock? As we talked in the previous, weathering of rock have two way: mechanical weathering that I already explained in the previous. And now is chemical weathering of rock. Chemical weathering cause both reducing in size and chemical alteration of the original parent rock. Yeah. It reduces size of rock and also change from original composition to another. We call chemical weathering. It is different from mechanical weathering. Mechanical weathering is reducing size and original mineral is still the same, not change. But for chemical weathering is reduce size and also chemical alteration of original parent rock. The chemical weathering include oxidation, yeah, hydration, and carbonation. Yeah, the picture show some sample of chemical weathering of rock due to interaction between rock with oxygen or rock with water or carbon dioxide. Oxidation. Yeah. Oxidation occurs when oxygen interact chemically with mineral. We call oxidation. Yeah, weathering, chemical weathering of rock by oxidation. It occurs when oxygen interact chemically with mineral that contain in the rock. And hydration. Yeah, hydration is from hydro. Hydro is mean water, refer to water. Occur when water interact chemically with mineral. Yeah. So rock can be weathering due to water. When water interact chemically with mineral that contain in the parent rock, it can be weathering. The last one is carbonation. Okay. Carbonation occur when carbon dioxide carbon dioxide interact chemically with mineral. Okay. We call carbonation. Okay, so chemical weathering have three main points. It's because of oxidation by oxidation, by hydration, and carbonation. Okay, transportation of weathering product. Yes, after it's weathering, so it can be stay in the same place, or can be transported or move from the origin place to another place, yeah, by wind or water flow. The product of weathering may stay in the same place or may be moved to another place by ice, by water, wind, and gravity. Okay. So the particle that come from the weathering of rock can be stay in the same place or move to another place by some factor like ice, water, wind, gravity, etc. The weathering products can be classified into two groups. Okay. Depend on the mode of deposition are following. Yeah. So the product that come from the weathering or rock can be grouped into two or classified into two groups. Yeah, depend on the mode of deposition. That is residual soil and transported soil. Yeah. So we classify it into two groups. First is residual soil, we call it residual soil, and another group we call transported soil. So what is residual soil? As you can see in the picture, yeah, this is bedrock or parent material, yeah. And then it will weathering by any interaction like air, mechanical, chemical, yeah, acid rain, and then it will become a small particle that we refer to soil, yeah, stay above the parent material or rock. So soil that stay in their parent or in their formation, not move to another place, we call residual soil. Residual soil that remain at their place of formation, yeah, in are called residual soil. Let's move to transported soil. Yeah. Group 2 we call transported soil or sediment soil. Soil that move and deposit to another place are called transported soil. For example, you can see in the photo, when the weathering product here at the top here at the on the hill or at the topography higher. So when it is weathering, and you can move to downstream by water or by gravity or topography or by wind, yeah, to accumulate or deposit at another place like along the river, stream or lake or sea. Yeah. Those are called transported soil. Yeah. The soil that move and deposit another place from their parent place or the original place. Yeah. Yeah, you can see here gravity driven slope. Yeah. Process move weathering debris to the base of the river valleys and allow for the transported by the river. Yeah. So soil can move along the slope and accumulate along the river or valleys and can be transported, yeah, along the river to deposit another place like in the sea. So this we call transported soil. Yeah. Yeah. In summarize, residual soil that remain at the place of formation, we call residual soil, and another one is transported soil, is the soil that move and deposit, yeah, to another place from their origin. We call transported soil or sediment soil. Yeah, transported soil or sediment soil. Okay, for transported soil or sediment soil, we can classify following. Yeah. This is the classified transported soil that we call alluvium soil. Is the soil transported by running water and deposit along stream. We call alluvium soil. It is one type of transported soil. Yeah. that transported by running water and deposit along the stream. We call alluvium soil. Another one is lacustrine soil. Also one type of transported soil. It's formed by deposition in quiet lake. We call lacustrine soil. Quiet lake refer to lake that the water not move, not flow. And another one we call marine soil, also one type of transported soil. It's formed by deposition in the sea. So the soil that transported from another place to another place, we call transported soil. And also we can divide it or classify in, according to mode of transportation, zone, or how it sediment. So transported soil we can divide into three: alluvium soil, lacustrine soil, and marine soil. Now move to particle shape. Particle shape of the particle shape generally can be divided into three major categories. You can divide it into three major categories. The first is needle shape, are available in clay mineral. Needle shape are available in clay mineral. It's very thin particle. Flaky shape are available in cohesive soil and are extremely thin. For needle, the section of the shape is round. And flaky is extremely thin. It also appear in clay mineral. Cohesive soil that refer to clay. Cohesive soil, or we can say clay soil. And another shape called bulky. Bulky are relatively large in all three dimensions, such as cobalt, gravel, sand, and shear particle. For needle shape and flaky shape in cohesive soil or clay. But for bulky shape, are relatively large in three dimensions, such as cobalt. Cobalt is like a rock. Gravel, sand, and shear particle. This is particle shape. You can see here for bulky particle, bulky that relatively large in three dimensions and have like cobalt, gravel, sand, and shear. Bulky. Bulky particles are formed mostly by mechanical weathering of rock and mineral. It generally come from mechanical weathering of rock. The shape of the particle we call bulky. Geologists use such term as very angular, angular, sub-rounded, rounded, and well-rounded to describe the shape of bulky particle. So as you can see in the below picture, yeah. Roundness and sphericity of the particle. This high sphericity, yeah, the upper row, this one, high sphericity and low sphericity for this shape. And we can divide it to very angular, yeah. Very angular for high sphericity, such as in this one, and very angular but for low sphericity, like here. The shape of the particle, yeah, can be very angular, and here is angular for low sphericity here, and for high sphericity particle here. Yeah, when it's transported long distance, it will become sub-angular or sub-rounded or rounded or well-rounded, depend on the mode of transportation and distance, how far it transport. So if the particle that move, yeah, far from the origin, it will become rounded or well rounded due to weathering surface of the grain. So this called shape like this we call sub-angular, and this sub-rounded, and here's round. And for sphericity, high sphericity is round, and low sphericity, yeah, like this, and well round, yeah, well rounded. Okay, we move to another point. Sand particles located close to their origin are generally very angular. Yeah. Sand particles that result from weathering product of rock that close to their origin, mean it not yet transported far away from their parent material, are generally very angular. Yeah, the shape of the particle or sand grain, yeah, sand grain is very angular for the sand that locate close to their origin. You can see in the photo so yeah, sand particle, different color, different shape, different size. Yeah, it's depend on the mode of transportation, the parent material, yeah, and how it weathering. Yeah, sand particle carried by wind and water for a long distance can be rounded in shape. Yeah. Sand particle that transported or carried by wind or water for long distance from their origin or their parent material, it can be sub-angular to rounded in shape of the particle. The shape of granular particle in a soil mass has a great influence on the physical property of the soil, such as maximum and minimum void ratio, the shear strength parameter, compressibility, and extra. Yes, granular particle. Granular particle refer to particle of sand or gravel. We call granular. Granular. It's refer to grain or sand grain or sand particle. Gravel particle. So its shape can influence, great influence to the physical property of soil, like maximum void ratio, maximum void ratio or minimum void ratio. Void ratio refer to the void space inside the soil, the void space connected between soil grain to another soil grain. Shear strength parameter, that is important for stability analysis of foundation or retaining wall. Shear strength parameter. So the shape is influent to this parameter also, and also for compressibility, for like settlement of foundation. Okay, so what is soil mechanics? We already know the original of soil, how it become. We already know soil is the weathering process of rock. The weathering process of rock can be divided into two ways: mechanical weathering and chemical weathering. That mechanical weathering have like flow action, abrasion, and exfoliation, and for chemical weathering have oxidation, hydration, and carbonation, and extra. So now what is soil mechanics? It from soil, the word soil and mechanics. Soil mechanics is the branch of science that deal with the study of physical property of soil, like grain size, and the behavior of soil, mass subjected to various type of force. Like I mentioned before, when the load apply on the soil, how it deform, how fast, how water flows through soil. In other words, soil mechanics is the study of both solid and fluid mechanical characteristic of soil. Solid refer to soil grain, and fluid refer to water in the soil. Okay, solid mechanics issue. You can see in the picture. Assume that this is the soil sample. And when we compress or apply load on the soil, it will deform or settlement or failure. So how much the soil will deform when it is loaded? How much it will deform when we load on the soil? For example, when you construct or build a house, you will construct a foundation, and the foundation is equal to a lot apply on the soil. So how it deform? When lot are applied, when lot are applied, on what rate does soil deform? How fast? What rate? Slow or fast or something? Another point, how much lot can we apply to soil before it fail? How much? Soil in natural is are different. So one type of soil to another kind of soil, it can be support the apply lot at different level. So how much lot can be applied to the soil before it fail? It refers to resistance or soil bearing capacity. How does it fail? How it fail? Like here, cylindrical specimen, soil specimen. When we apply load or pressure on the surface of the soil, it will deform, like in the picture B. Deformation under load. When we load, it will set tall or deform. For fluid mechanic issue, how does water flow through soil and how fast? You can see in the picture, so different soil type. Like this one is granular soil. Granular soil, granular refer to sand or gravel. Primitive refer to some soil that have flat particle. And this subangular blocky mean subangular soil grain. The water can flow different way. It depends on the size and shape of particle, soil particle, size and shape of soil particle. This is platy. This mostly clay, platy size shape. The water can flow very slowly to pass the clay layer, but for sand or gravel it can flow faster due to the void space between soil particle to soil particle is large or small. How can fluid flow through soil cause it fail? How it fail? Like in the photo, we can see this is the earth dam. Earth dam. We construct here earth dam to store this water at the upstream. If the construction material or soil material that we use for construct this earth dam not good or not good design, it will failure due to some factor like soil bearing capacity failure, like water flow through soil that cause it failure, and another mode of failure. So why do us civil engineers study soil mechanics? Why civil engineers study soil mechanics? In brief, all branch of civil engineering require an understanding of soil and how it behaves, namely structural engineering, transportation engineering, environmental engineering, and hydraulic engineering. All of these are civil engineering. So all this work related to soil mechanics, all construction, all structure, and construct it over soil. So we must know about soil mechanics to ensure our structure will be safe. So now structural engineering. Practically all civil engineering type structure eventually come into contact with soil via their foundation. For example, bridge, office, and resident building, tower, road embankment, earth dam. All of these are come to contact with soil via their foundation. So the knowledge of soil mechanics is essential to ensure that the structure are properly supported. This can prevent structure damage and failure. Can prevent structure damage and failure, loss of life, and financial loss, etc. As you can see in the photo, shows about building collapse. It can be a cause of many factors, like such as earthquake, tsunami, storm. And underground soil is low bearing capacity that cannot support the very high load from the superstructure. So this building can have problem cause of one of the above factor. It's important is soil, related to soil that support the foundation. So the cannot support the weight of the building. So soil mechanics is very important. Even we build our building with high quality, you can see in this picture, yes, the body of the structure seem very good, still the same condition, not break, but due to their foundation is not good or not enough bearing capacity, it can make this building collapse. So it will loss of life, financial, due to big understanding about soil mechanics and foundation. So from soil mechanics, we can design or what type of foundation we should use for our structure or our building. For example, this is all about footing, or we call cello foundation. So how we know when we use cello foundation, or when we use dip or pile foundation? Before we know what type of foundation we should use, we need to know what type of structure that will be constructed, and the underground soil condition, how weak, how strong. Yeah. If the soil condition, if the subsoil condition is very weak, so we must use deep foundation or pile foundation. Yeah. If the shallow soil, if the shallow subsoil is good, sometimes we can use shallow foundation if our structure is not high load. Yeah. This picture show example of deep foundation, that is driven pile. This structure lot from superstructure, and here is a pile. Yeah. We install the pile to the high density of soil or hard soil. The high density of soil refer to hard soil. Yeah, lower density of soil refer to softer soil, softer soil or weaker soil. So the pile foundation should install to the hard strata or hard soil layer, or high density soil. And this is a pile cape that connected pile head together. Example, and it's a pile that they install install at the side by driving or by check or by boring some. Yes, for transportation engineering, we already talked about structural engineering, why we need to know about soil mechanics or study about soil mechanics. And now about transportation engineering, why we study soil mechanics. Roadbeds are often built of soil, and the roadway themselves can often pass through mountain, cut, field, etc. We already know that roadbed or embankment or road embankment are built of soil. Understanding soil mechanics can prevent problem with pavement potholing and cracking, as well as embankment and slope failure that can wipe out entire roadway. So we need to understand about soil mechanics to prevent problem that can be occur during and after construct our roadway. For example, in the photo, you can see the pavement cracking. Here crack, pavement. This can happen due to the underground soil foundation of this road. Soil is not good, like expansive soil, but expansive soil or swelling soil or weak soil. Expansive soil is referred to the soil that can swell when it wet. When it wet, it can swell. The volume of the soil can be increased 10 or 30 times from their origin volume. That called expansive soil, can swelling when it's wet. So if the soil that is the foundation of the pavement is swelling soil, so when it wet, it will be swell. That is increase pressure to push the pavement of road that become to deformation or crack. that this can happen in rainy season. Also during dry season, that swelling soil can be shrink. Because string it means their volume will decrease, like so in the picture. Due to the shrinkage, the soil will be cracked like here. Will crack. This crack has force, have force, tension force, that can make the pavement crack. We need to investigate or study or understanding about soil beneath the roadway or under the pavement before we construct the roadway. We need to take it to testing to know the parameter or property of the soil. It is swelling soil or shrinking soil or what. If the soil is swelling or shrinking, we can remove that soil and replace by a quality soil or good soil, to reduce their swelling or cracking, or to increase the bearing capacity. Yes, just example. This picture also shows us about failure of roadway, due to water flow through the roadway or through the soil. This happens generally at a mountain area that have water flow through the roadway and cut out the roadway. So to protect this really happen, we need to construct a drainage or something to remove water, not allow to flow across the roadway like this. That can erosion and sometimes can slide like here. To protect or prevention this, we need to compaction or construct a retaining wall, install drainage. In this wall we can install a pipe or something to drain water. So you can prevent the failure of the roadway due to water flow through the soil. Can improvement, this upgrade like here, improve by compaction or make with another material like lime cement or something to improve the bearing capacity of soil. The environmental engineering also need to study about soil mechanics. We already discussed about transportation engineering and structural engineering. Now environmental engineering, like liquid toxic or pollutant often spill or release inadvertently onto or into soil. They can make the soil or water underground water pollution, make it pollution. And when people use the water, underground water, it can affect to their health. Yeah. Landfilling of solid waste. Yeah. As a result, important questions that need to be addressed are: will the pollutant remain in place or possibly be transported through soil? If so, on what rate? I already mentioned that water can flow through soil. So if we polluted the soil, so water inside the soil also polluted, and it can be flow, yeah, underground water can flow from one place to another place. Yeah, and the rate of flow is depend on type of soil, like clay, sand or gravel. It have different permeability. Yeah. So we need to study about soil mechanics to know that what soil has high permeability, yeah, high permeability, what soil have low permeability, and what rate, and how much, yeah, how much the permeability of the soil. Yeah, that is important for protect pollution in the water or underground water. Can anything be done to clean up the pollution, like providing barrier and other remediation measure? Yeah. So we want to protect or prevent the pollution, so we can make a barrier or boundary that water cannot flow, or very low permeability that make the pollution cannot transport long distance. Like in the photo is, yeah, landfilling. Yeah, we call landfilling was. Soil pollution defined as the change in physical, chemical, and biological condition of the soil through man intervention, resulting in the degradation in quality and productivity of the soil. So the pollution can change physical and can change physical property of soil, chemical property of soil, also biological condition, yeah, of the soil. Hydraulic engineering. Yeah. About hydraulic engineering, the design of earthen flow retention structure such as dam, levee, dig, storage pond, etc., require knowledge of how water is transported through soil. Yeah, I mentioned before. Yeah, how much it can flow through soil, how fast. It also requires that to know how water flowing through soil can cause failure by mechanism such as cracking, piping, erosion, etc. Such as in the photo, we can see that there is a dam that constructed for storage the water at the upper stream. Yeah. So if we are not design, yeah, good design, or the material that we use not good, that can allow water flow easily. Like here, you can flow, like have a potholing or cracking like this, and later it will be erosion. Time by time it will collapse like in this picture. And this is an example for design the dam. We can use here is we call core this gray layer. This can be an impermeable layer. This means water cannot flow through it, or very low that allow water flow through this layer. And another layer can be shear or rock, make something like that to protect the erosion. And this is important to control the permeability of water. Just an idea for constructing the dam. This picture also how to prevent the failure of dam. Here is earth dam. This is water. So the water can be flow. We call phreatic surface. Water can flow like here. And you can install a drain here, like a drain layer that allow water from here accumulate in this drain and then flow out here. If we not install this drain, the water can flow through here and make erosion in this zone. So time by time it will be failure. And this one also another example. This one also. Rock fill dam with centrally local core. This is core. And this foundation and this outer shell. This can be filter. So water can be filtered here. This also this surface of the dam can be like rock net protected by granular material, and this we call core that allow water flow through it very slow. And this can be a filter layer or drain layer that can drain water flow to here. Okay, so in summary, the essential point are for the lesson. Soil are natural resources originally from rock that we already talked. They are necessary for our existence. They provide food, shelter, construction material, game. They protect the environment and provide support for our building. And definition of soil mechanics is the branch of science that deal with the study of physical property of soil, and the behavior of soil mass subjected to various types of force. And knowledge of soil mechanics is essential to assure that the structure are properly supported. This can prevent structure damage and failure, loss of lives, and financial loss, etc. So this is the importance of soil mechanics. Okay, so this some reference box that you can find in Google, or I also upload in Classroom, so you can download it. Okay, for our next lesson is soil investigation. Soil investigation. So, what is soil investigation? How we do a soil investigation? What step in soil investigation? Yeah. So we will learn about soil investigation for the next class. So today class is end.